Thank you, welcome everybody, and as you can see, my name is Natalie. I'm a PhD student. I've only just started, well, back in October with my research, and as I go through I'll start to reveal a bit about my background, but I'm not going to tell you all of that for a start. I'm going to start first of all with a question. What do you think is the best invention or discovery that humans have ever made? Answers, please. The wheel. Okay. Anybody else? Electricity. Plastic. Sorry? Plastic. Okay. Didn't get plastic on my list. Anything else? Phones. iPhones. Yes. Cool. So I've put up some ideas there. I was going through things like the printing press. The first time people were able to make books very quickly. I've got the space shuttle. It's the first time people went into space. Telephone, whether you recognise that picture of a telephone I've put up there, I don't know, because I used to teach children and they used to show them the dial telephone and they had absolutely no idea what that was. Computers, the car and other things. So my favourite invention, what is that? Anyone know? It is what sort of a furnace? Yeah, it is a blast furnace. So my favourite invention is the invention of man's first time of making iron. Because before steel came the ability to make iron. And they used to use a furnace. They would put in iron ore, coal and fluxes and turn that into iron. Then at a later stage, humans discovered how to turn iron into steel. The difference between the two is quite important. There is a lot of difference in the structure. There's carbon in iron and there isn't so much carbon in steel. Steel is much stronger, but it took many years to get to discover how to do that. Putting all this into context, this slide shows the proportions of different materials as made in the world at the moment. You can see the huge proportions of cement, followed by steel, plastics, paper, aluminium and other materials. This is just to give you an idea of the volumes that are made every year. When we manufacture things, the big problem that we have is that a lot of manufacturing processes are responsible for making carbon dioxide. And we all know that our biggest challenge that the world faces is to actually reduce the amount of CO2 that we produce and to help our climate crisis. Steel is responsible for approximately 8% of the man-made carbon dioxide in the world today. That's quite a lot. If we compare other materials, then we can see that if you see that a balloon represents a proportionate amount of CO2 released for each material, you see that cement and paper are the very lowest ranking, followed by steel, then plastics, and look at the amount of CO2 that aluminium releases per tonne of production of aluminium. So there's 10 tonnes of CO2 for aluminium and about 2 tonnes of CO2 for steel. It's just to give you an idea of and a comparison. So I promised I'd tell you a bit about my background. The middle picture there that was my first job. I had the most exciting, very, very, very nerve-wracking job of actually making steel. And that was a while ago, but I used to actually, the middle picture, I used to actually stand there fully dressed in protective equipment with a radio, giving instructions for that actual process of making steel. It was very exciting. And I felt very important doing that. And I've always been an advocate for steel ever since. And why am I an advocate for steel? Well, I think it is true to say, the statement I've got on the bottom here, that virtually everything is made of or using steel. Think about all your other things that you do in your life. Look around you now. The amount of this room that is made of steel, the seats you're sitting on. Think about the other materials that we make. We make plastics. Yes, we make all other exciting things. We make batteries. But I guarantee in that process somewhere there will be steel. that will have made the equipment to make it. Somewhere along the process, you cannot do without steel. So I've just put some pictures up there. You can see I used to live near the bridge. In fact, I used to live 5 miles from the bottom of that bridge. Used to be one of the longest bridges in the world. That is the Humber Bridge up in North Lincolnshire. You can see on the second picture there are pictures of more construction steels. We've got cars made of steel, wires. We have medical equipment, fixings, fasteners, you name it. Those things are all made of steel. We cannot, I don't think, as a race, actually do without steel in our lives. So, going back, we need to get our metals from somewhere. You've heard presentations earlier where people were talking about lithium and batteries and sourcing things from the world. Well, we have to dig iron out of the ground. It doesn't come as the metal you recognise. We have to dig it. It's iron oxide. And there are many processes that you have to go through to actually remove the oxygen from iron oxide so that it turns into iron. And a long time ago, hundreds of years ago, they discovered that obviously by roasting it with carbon, you can remove that oxygen. And you only need 1.6 tonnes of iron ore to make 1 tonne of iron. That's not actually too bad. That's because each of those ores contains about 60 to 70% Fe, which is actually fairly good. Now, 3 billion tonnes a year of iron ore is mined. That's turned into 2 billion tonnes of steel. That's a phenomenal amount. And the figures that go with that is that of all metals mined in the world, 94% of it is iron, so turning into steel. And of all the iron ore that's actually mined, the 3 billion tonnes, 98 of it goes into steel making. So that's quite a phenomenal amount. We know, as I've just mentioned, that the way to turn the iron oxide into iron, you need to remove the oxygen. And the way that you do that is by adding carbon at the moment. This, unfortunately, is responsible for a huge amount of carbon dioxide, as I have said already. Now, this is a very cheap process at the moment. So the people that discovered it hundreds of years ago did a fantastic thing. They made a very, very efficient and cheap process. There's nothing wrong with that, except for the fact that unfortunately now we've realised that this CO2 is now causing a big problem with the planet. We need to do something about it. So we need to move towards zero CO2 steelmaking, carbon dioxide steelmaking. And it is feasible to do this using hydrogen. And as long as that hydrogen is green hydrogen, that means hydrogen produced using renewable energy, then this is going to be a solution for the steel industry. Unfortunately, it is not an immediate thing that can happen. Everybody is competing for the green hydrogen that is being produced around the world. Everybody would like to have it to power cars, to heat homes, to do all the other things that people want to do. Everybody is talking about hydrogen, and we would all love the green hydrogen that is there. A lot of things have to be considered first, like the safe transportation, the safe storage and everything of hydrogen, but it's very, very important that all those things are going to need to happen. But hydrogen is going to be a solution for us. It is just when is that going to be able to happen. And the reason it's a solution is because hydrogen loves to combine with oxygen, and so therefore if you were to just roast your iron oxide in an atmosphere with hydrogen, you produce water. And we all know that that is not going to be causing us, hopefully, any problems. As long as we don't pump all that water vapour up into the atmosphere, then that's not actually going to cause us any problems. So the green hydrogen sector is currently very small, and many industries see it as their way of decarbonisation. And that is where there is, at the moment, the problem. So what are we going to do in the meantime? We need to move towards decarbonising the steel industry while we wait for this green hydrogen to become available so that we can make our steel that way. So this now comes back into why my project and what I'm doing here at WMG. So I started in October on my PhD, and I am trying to find sustainable ways of making steel. At the moment, the most practical way of that is actually to increase our amount of recycled steel. Everybody understands the idea that reduce, reuse and recycle. It's our way forward. And that is a responsible way to live on this planet, that we must reduce what we use. We must reuse, then we must reduce and recycle. So my project is looking at ways of recycling. So I'm going to be spending 3 to 4 years literally looking at that lovely stuff at the top there, scrap, and how we can increase the amount of scrap that we use in making steel. Why is that important? Why is that such a good thing? Well, recycling and using more scrap, for every tonne of scrap, you are saving 74% of the energy that you would if you were using the materials just dug out of the ground. So you can see I've got 2 pictures at the bottom here. So that schematic here shows the amount of coke or coal that is saved, the amount of iron ore that will be saved, and the amount of limestone as well that make fluxes that help us to make steel. So all of those materials are going to be saved if we can recycle our scrap. At the moment, and there is a lot of scope for this, because at the moment the UK only uses 25% of the 10 million tonnes of scrap that it actually has going around in the economy. Now, it's not to say that the other 90% is wasted. It isn't. It goes abroad. Everything goes and is sold, and other people use it around the world. It is fully utilised at the moment. So that there is actually, they think, 500 million tonnes of steel in the UK sitting there waiting for us to use. We just need to find a way of doing that. And that is what my project is going to be, and that is my challenge. So, thank you very much.